Oh, sorry. Sorry about that. I'll turn that one off. So sorry about that, Mr. Nye. Yeah, that was probably a little too bright, wasn't it? My name is Mr. Burns. I'm just gonna ask you a couple questions. We're trying to figure this thing out. So I'm not here to send anybody to jail. I'm simply just here to, it's kind of mandatory. I mean, you probably know how it is, right?
Yeah.
Cigarette?
No, thanks.
So there's a specific person we are looking for.
Didn't you just like that?
In this briefcase, I have some items.
Okay.
And I want to see if you recognize any of these items in the briefcase. This is not one of those items. This is just for me. Do you know the famous physicist Isaac Newton?
No.
No, not at all.
Mm-mm.
One of the most famous physicists in the world.
No.
Interesting. Well, do you know that he had a couple laws?
I didn't know who he was, so no, I did not.
Really? You didn't know at all? You don't know how many laws he had?
Nope. Did not know.
Well, I'll inform you because I'm just trying to help us get to a common ground here. He had 3 laws actually, and why don't we get started with the first, shall we? So the first of Isaac Newton's laws is that objects in motion tend to stay in motion. Does that ring a bell at all?
No.
No. Okay. Well, then I guess I'll just have to do some kind of demonstration, right? Are you more of a visual learner or?
It doesn't matter.
Well, I'll just assume that you are more of a visual learner. So, for the demonstration,
I don't know how that.
well, clearly you didn't get that first one, so maybe we'll move on to the second one, shall we?
Yeah. Sure.
Okay. Oh, perfect. It's this one. I love this one. Let me bring out my piece of paper. Maybe you need more of a visual cues instead of me just explaining it. Here we have this equation. Do you recognize this equation at all?
Nope.
No? Okay. Would you mind reading it out to me?
F equals ma.
Very good. You can read. So this, all the letters actually mean something. I'll explain to you what those mean. So the F here, we have an F. That stands for friction. Friction equals, you know what an equal sign is?
Yeah.
Okay, beautiful. Then we have the M and the A. And now the M and the A are multiplied together. The M stands for mass. The A stands for acceleration, meaning friction equals mass times acceleration. Does that sound familiar at all?
No.
Oh, well, no matter. I'll use a visual demonstration then, even though the visual cue didn't work. I'll do another visual demonstration, shall we? So here I have my handy dandy ball, and watch what happens whenever I just drop it from a height. Well, it didn't go very high, did it?
No.
Well, then watch what happens whenever I throw it on the ground and increase the acceleration if you get me. It cracked. Oh, so sorry. Mr. Nye? Mr. Nye?
Oh.
I'm back for the demonstration. I'm so sorry. I didn't mean to be gone for so long.
How long was it?
It doesn't matter. It's just got back into it. Where? Oh, that's where we were. The second law of motion.
Yeah.
Well, I had to go get another ball, so let's just keep it going, shall we? So I have this ball here, right, Mr. Nye? And see what happens whenever I drop it. That didn't go very high, did it, Mr. Nye?
No.
Let's see what happens if I throw it onto the ground, increase its acceleration, shall we? It went up quite a bit higher, didn't it?
Yeah.
That doesn't mean anything to you, Mr. Nye?
Does not. Nope.
That means nothing to you.
Nothing.
Well, then let's just move on to the third one, shall we? The third law of motion. You don't know it at all?
I didn't know the other two. So, no.
Well, the third law of motion states that for every action, there is an equal reaction. And clearly, since you don't know it, let's use this little handy-dandy device that I have here. Do you know what this is, Mr. Nye?
I do not.
No. This is what we would like to call a Newton's cradle. Do you know what the Newton's cradle is? Do you recognize the name at all?
I do not.
No? Well, we're looking for Isaac Newton, or people that know Isaac Newton. And we have Newton's cradle. Do you see the correlation there?
Yeah.
Well,
Right.
let's take a look at the device itself, shall we? What happens, do you think, whenever I drop this metal ball? What happens?
It might stop. I think it'll stop on the other balls.
It'll stop.
Yeah.
Oh. How about you go for it then, Mr. Knight? Pick up the ball on the end, on your end, and let go of it. And let's see if it stops, shall we? Doesn't seem to stop, does it?
Nope.
And that means nothing to you.
Does not mean anything.
That means nothing.
That means nothing.
Oh, choose your next words very carefully, Mr. Nye. If I were you, I would be completely honest with my next words. That means nothing to you.
It means nothing.
You're lying to me!
It means nothing, I swear. I swear it doesn't mean anything to me.
You leave me with no choice, Mr. Nye.
What do you mean?
I know you're lying to me.
Okay. Yeah. I wasn't telling. I was.
Much better.
The first one. You forgot objects at rest tend to stay at rest as well, and you didn't say the acted upon by an external force. You flipping the table. You being the external force. The second one.
Look at me in my eyes.
The second one with it's force equals mass times not friction. It's force. You bouncing the ball. You higher acceleration, more force, total whatever. The third one, each reaction has an equal and opposite reaction. You forgot to add the opposite. With the Newton, how it goes the opposite direction than what you had originally. It'll energy whatever. That's all I know.
Did you guys get that?
Yeah.
Good. Send in the squad. Well, Mr. Nye, seems that our little party has come to an end, hasn't it? Seems that you did know the entire time. And it's quite funny, really. You were a lot easier to track than I might have expected. Well, get your things, and we should be
Mr.
going.
Burns.